Today we're looking at how to diagnose and possibly fix a starter motor. Bit of safety first. We are talking extremely high current. If you end up getting a ring, a watch or a spanner stuck between any of the cables on a starter motor, you can end up with some serious fires or some serious burns. This is just to show you how this stuff works, get an idea. If you do it yourself, it's at your own liability. Right, so these things are pretty simple. What you have got is you have got three terminals. So what you've got here is you've got your main power in from the battery and your power from the switch. You've then got an exit cable that goes into the starter motor. Right, okay, let's talk noises first of all, okay? You will have heard one of three noises if you are having a problem with your starter motor. You will have heard the click, which sounds just like a click. You will have heard the whir, which is where your starter motor, you can hear it spinning, but it is not turning your engine. Or you will have heard the nothing, and yes, the nothing is a noise. So, what do you do? Well, first of all, let's look and see what we've actually got and how this thing works so that you get an idea first of all. Now, I've shot this video 3 times now, and each time it went on for about 5 hours, so I'm going to keep this short and I'm going to keep it simple. Right, in here, this thing here is a solenoid. What this solenoid does, it's a coil of wire, and it's very simple. Power to that one there energizes this coil and it yanks this piece of metal in. That piece of metal has 2 jobs. Number one, it does, see down here? See that gear getting shot out so that it can engage the flywheel and actually turn your engine? That's one job. And the second job is, see these 2 big bolts here? Behind there's 2 contacts inside, one there and one there. This piece of metal flying back pushes a copper bar to contact those 2. So then power from the battery goes down to the starter motor. So this is your click, okay? Your click is this thing. If you're only hearing a click, only this is working, or only this is working partly. Because what this can do is this can throw across, and it can pull the little gear in, so it can pull the gear out so that it's right, but maybe it's not pulling hard enough to actually contact those 2 in there. So, okay, how do we diagnose, how do we troubleshoot, how do we know? Right, first things first, what we do is, now bear in mind, like I said, you can end up, the power of the cranking power of a battery is about 500 amps quite often, and that can do some amazing things. I mean, that can make a spanner go red hot, that can burn your wedding ring in half, that could do all kinds of things. Right, so what you're doing is you're taking something metallic from this contact here, which is the power in from the battery, and you're touching the starter connection there. Now, if you're only getting a click, so you're down there, you're only getting a click, what you know is that this is throwing it across, but it's either not contacting it, or the starter motor itself is not working, so the actual motor. How do we tell? Right, what we do is we bypass that connection. So what we do is we go from this input from the battery straight across to the big one at the bottom, there. Now, if the motor now runs, it goes whirr, and you hear the motor run, you know the motor should be okay, and the problem's in here. So, if you're in a hurry, by the way, what you do is you contact that one and that one, you join those 2 together, click, and that one as well. So what you're doing there is you're actually using the throw of this to throw out the gear out that way, so that it hits the ring gear. And you're also then bypassing the switch in here, or the contactors in here, which obviously aren't working. That'll get you going nice and quick. So what you do is you are throwing out that gear, and you're then making the switch that it can't make itself. Right, okay, troubleshooting these things. Right, well, that is your standard fix, which is a bit of a tap. Not here on the plastic bit, you'll break it. Bit of a tap. Other things, you can find that it's got all caught up in here, so you can end up, you know, some WD-40 down here can help to get this freed up, and also similarly some WD-40 up in here. This slider here can get stiff. Now, distressingly, you can't take these apart anymore. You used to be able to take them apart. My starter motor is falling to pieces because I've taken it apart to not bore you by seeing me with a spanner on camera. Right, you used to be able to take these apart, you can't anymore. The tapping, by the way, sometimes releases some crud that gets between this contact and the plate at the back. Anyway, these are cheap enough. They're not that expensive, as you see. They come off with 2 bolts. There's 2 bolts that sit at the front there. Dun, dun, dun. There we are. Cheap and easy to get. You can change them. You don't need to take the starter motor off the car. Sometimes it's easier though, to be fair. If you're on the piss, that's my fault. There we go. Right, so there's that. WD-40ing this sometimes helps. I mean, to be honest, it doesn't last very long. WD-40 is not very good for these. I don't know why. It works a couple of times and it dies, and it goes back to what it was. But it might get you out of trouble quickly. Right. Okay. Let us assume that you have contacted those 2 and there's nothing happening. It means your motor's knackered. So, what do you do? Well, these motors aren't all that complicated. There are, I mean, they're not the simplest thing, but they're not that complicated. Usually it's a permanent magnet motor. Sometimes it's not, but so you basically got a brushed DC motor. We're not going to look at the windings and things like that, but if you take the bolts off the back and take it out, now usually, unfortunately, but not on this one, what happens is the rotor, which is this, separates from the brushes. So what it actually does is it ends up, this jumps out and you're left with the brushes hanging out and that sort of thing. But for some reason this one doesn't come apart. So you're now really only left with 1 or 2 things. Checking to see whether these huge wires have overheated and burnt out. So you'll be able to see, so if it's all nasty you can see. Or it's your commutator bars, which is these copper strips here. Or it's your brushes, which are these things. There's one taken out for easy access. Right, okay, so what can you do? Well, the first thing is check your commutator. Now, you see this one? You see that nastily pitted horribleness there? Well, that's what's happened to this one. So, what do you do? One of the simple things is to get a bit of sandpaper, and usually yours will be out, so it'll be easier to get your hands on, but with this one where it won't come out, all I can do is I can squeeze that in there and just, careful not to catch the front, you can just get those cleaned up. You want to get rid of grease, dirt, all those sort of things. Brake cleaner is useful for this. And you can get that back to a nice shiny condition. Similarly, with the brushes, you want to make sure that they are actually pushed to the bottom. So you check that the springs here are actually pushing them to the bottom, because they can snag in their carriers. So you need to make sure there's still some brush left and they are pushed right to the bottom. You then need to make sure that the brushes aren't obstructed with grease. This is what the problem was with this one. I think that's the reason it burnt out. It's because the grease got on these, and then what it did is it started arcing every time it passed that segment there. Now, there is actually a fair amount of material on these copper bars. I mean, there's not inches of it, but there's a bit of it, so you can polish them quite hard. At the end of the day, if you can't polish them back to a reasonable state, the rotor's knackered anyway, so there's not really any. You've got nothing to lose. So yeah, polishing them back. Now, those are pretty much the only 2 things you can deal with. You're not going to be rewiring this monster wiring here. You know, it's not really feasible. The other thing potentially that can be a problem is the little bearing at the end here, allowing this end to flop about too much, at which point it loses contact with the brushes. You can replace that temporarily with almost anything, because this end of the motor doesn't really do that much work. And remember that a starter motor doesn't really turn all that much. it's not really rotating and rotating like maybe an alternator is. It's just doing a few rotations and off you go. High torque, short duration. If you try running a starter motor for more than a few minutes, you'll see exactly what I mean. Because they've got no cooling whatsoever in them. There's no cooling fan, there's nothing. They just simply for quick bursts. Right, okay. So let's talk about some of the common pitfalls. Now, if you can imagine, you see this section here. Imagine that section there is like this, okay? And all the brushes are sticking out here, 1, 2, 3, 4. You've taken out your rotor, poof, and all your brushes go ping into the centre. Oh God, how do you deal with it? Right, well the trick is, what you do, now imagine this is that copper end bit there, and this is around the bushes like that. The stub that sticks off the back of this that goes into the bearing is quite thin. So imagine like that. Okay, so it's thin down there. So what you can do, I'll take it off because it won't poke through the back of here. So what you do is you take the thing, this is the copper bars here, put it in between the brushes, and these brushes are going to be poking out all over the place in here, 1, 2, 3, 4, and it won't fit in because they're in the way. So what you do is you turn it slightly on one side, catch the edge of the bottom brush, push it back into its holder, push it down back into its holder there, and angle it the other way like that to catch the next one, push it out of the way, and then you should be able to get it in. If that doesn't work, you can look at moving the brush springs out of the way, which is actually, to be fair, easier said than done in most instances, because as you can see here, they're not really going to want to come off, and you can pick them off, you can do all kinds of things. But really, if you can clean up those brushes, even if you leave it in situ, and clean them up with a bit of sandpaper in between, like so, getting them back to a nice condition. Degrease them, because quite often when it gets hot, what happens is the grease comes out of the bearing at the back. The grease then goes on the brushes then don't conduct electricity as they should do, and it doesn't work. So there we are. Listen, in recap, oh, by the way, a couple of other things. If you're in a real bind, what you can do, and your starter motor isn't working, what you can do, so imagine it's the actual motor, and it's not the solenoid. If it's a solenoid and you're in an urgent hurry, you're going to be giving it a little tap with a hammer. That should dislodge any debris, maybe, or it might even free off the plunger that runs back. That one. You can try that, but again, don't hit the plastic bit, and don't hit it too hard either. The other thing is that if you're in a desperate situation and you have got what I've got here, which is burnt out there. Now imagine that burnt out bit there is on that brush there. You click the starter motor, the power is sent from this down to here, but it can't turn because it can't contact. What you can do is you can see, because mostly they do this, what you can do to try and shift this starter motor off that section, what you do is you click it so that it throws out this here. So you click it and hold it clicked so that this is engaged with the flywheel. You put the